Hello, my dear students. In the last two videos, I explained what are types, different relations. Now, in this video, I explain special types of relations. Actually, in the two videos, I have started basics of set theory, different types of sets, operations of sets, and so on. And also relations I define. What is the relation? Now there are three main special types of relations. First one is, it is called reflexive relation. Reflexive relation. Reflexive means, what is relation? Relation in a set, non-empty set A is subset of A cross A is. Subset of A cross A. That is called a relation in a set. Now relation R is said to be reflexive if for all A belongs to A, ordered where AA belongs to R, then R is said to be reflexive. Second, a relation is said to be symmetric. Second type of relation is symmetric if a relation R is said to be symmetric. Said to be symmetric if AB belongs to R implies BA belongs to R. Or we can add here, for all AB belongs to R, BA also belongs to R. It is called symmetric. Next is transitive. When we say that relation is transitive, transitive means a relation R is said to be transitive. Said to be transitive if AB belongs to R, B.Sc belongs to R, implies AC belongs to R. Then R is said to be transitive. So relation is reflexive, symmetric, transitive. Now what is the example for reflexive relation? Example for reflexive relation is, suppose capital A is ABC. Then relation R1, I take relation R1 as AA, AB, AC, or BB and CC. Now this relation is reflexive because for all ABC belongs to A, order pair AA, BB, CC are there. Therefore it is reflexive. Symmetric means same set. Take A is equal to ABC and I take R2 is equal to, it is subset of A cross A. It is AB, AC, BA, BC. Then it is symmetric. Transitive example, say take same set A and R3 is, it is defined like this: AB, AC and AB, AC, take BC, then AB, BC means AC, and B, BA, AA. What is the relation? Subset of A cross A. A cross A consists of 9 elements. I have taken 1, 2, 3, 4, 5. And I have taken 5 elements so that when AB, BC are there, AC is also there. AB, BC and AC is there. And AB, BC, AC. And AB, BA, AA is also there. Therefore it is transitive. So, the relation is said to be reflexive, may be symmetric or transitive. These are the main types of relations. And next is important, the concept of equivalence relation is very important. While studying the next topic, this plays important role. Equivalence relation. Equivalence relation. A relation definition, a relation R in a set A is said to be equivalence if it is reflexive, symmetric as well as transitive. Then it is called equivalence relation. Definitions here. A relation R in a set is said to be equivalence if it is reflexive, symmetric as well as transitive. Now we consider example for that. I take some examples here. For equivalence relation, I take directly for an example for equivalence relation. First example, let L be the set of all straight lines in a plane. What is the non-empty set here? Set of all straight lines. And R be the relation in L defined by X is parallel to Y. For all XY belongs to L. Then this is an equivalence relation. What do you mean by equivalence relation? It must be reflexive, symmetric as well as transitive. Now, why it is equivalence relation? First of all, it is reflexive. Why it is reflexive? It is reflexive because what is the relation here? Is parallel to, and we know that X is parallel to X. Any straight line is parallel to itself. Therefore, relation is reflexive. Or in other words, Xx belongs to R for all X belongs to L. In terms of mathematical language, you can write like this: Xx belongs to R for all X belongs to L. What do you mean by Xx belongs to R? Relation is parallel to L. X is parallel to X. Any line is parallel to itself. Therefore, it is reflexive. Second, if X is parallel to Y, then Y is parallel to X. In terms of our notation, if XY belongs to R, then YX belongs to R. What do you mean by XY belongs to R? X is parallel to Y. X is parallel to Y implies Y is parallel to X, because take two lines, X and Y, parallel lines. This is X, Y. X is parallel to Y implies Y is parallel to X. Therefore, it is symmetric. Third one, it is transitive. How do you prove that it is transitive? Transitive because suppose X is parallel to Y, Y is parallel to Z. Three lines: X, Y, Z. Three lines. X is parallel to Y, Y is parallel to Z. This certainly implies X is parallel to Z. This implies X is parallel to Z. In terms of our notation, mathematics has its own language. We have to use this mathematical language. In terms of language, how do you express this? XY belongs to R, YZ belongs to R. What do you mean by XY belongs to R? Relation is here, is parallel. Therefore, XY belongs to R means X is parallel to Y, Y is parallel to Z, implies X is parallel to Z. Therefore, it is transitive also. Hence, the relation is reflexive, symmetric, transitive. Hence, this is parallel to is an equivalence relation on set of lines in a plane. But however, is perpendicular to, is it an equivalence relation? Is perpendicular to on set of lines in a plane is not equivalence. It is not equivalence relation. Why it is not equivalence relation? Because this is not reflexive at all. It is not reflexive. When you say that relation is reflexive, if xx belongs to R for all x belongs to A is the set here. Suppose A is the set of all lines, then xx belongs to R, then you say that it is reflexive. When you say that xx belongs to R, in this case, xx belongs to R means relation is perpendicular to x is perpendicular to x. Is it true? X is perpendicular to x? No, it is not true. Any line is not perpendicular to itself. So, it is not reflexive. Hence, it is not an equivalence relation. What is equivalence relation? It must be reflexive, symmetric, as well as transitive. Then only it is equivalence relation. Second example for equivalence relation. Let capital A be the set of all triangles. Triangles in a plane. Let R be the relation in A defined by x is congruent to y. Then it is equivalence relation. X is congruent to y. Then it is equivalence relation. Why it is equivalence? Say I explain like this. Why it is reflexive? Any triangle is congruent to itself. Why it is symmetric? Consider two triangles. These are the two triangles. Suppose x is congruent to y, then y is congruent to x. You know what are congruent triangles? Similar triangles. Similar triangles are different. Congruent triangles are different. Congruent means exactly same. Two triangles are exactly same. X is congruent to y, then y is congruent to x. Therefore, it is symmetric. Now, x is congruent to y and y is congruent to z. Y is congruent to z. Then what happens? X is congruent to z. So here, x is congruent to y means xy belongs to r, yz belongs to r, implies in terms of language, mathematical language, xy belongs to r, yz belongs to r, implies xz belongs to r because x is congruent to z. So finally what happens? This relation is equivalence relation. Sometimes a problem may be asked on this equivalence relation. Therefore, I consider some more examples here. You take next example, third one. Example is like this. Let I be the set of all integers. Let us define a relation R in I such that x r y holds if and only x minus y is divisible by 5. What is the relation? X or y. What do you mean by another notation? Here it is one more notation. x or y means x is related to y. X is related to y under the relation R, and R is defined like this here. When x and y are related, if x minus y is divisible by 5. Now, verify whether it is an equivalence relation. What do you mean by equivalence relation? Equivalence means reflexive, symmetric as well as transitive. First one, reflexive. Why it is reflexive? When you say that relation is reflexive, x must be related to x itself. What is the relation? X minus x is divisible by 5. Divisible by 5. Is it true? Yes, because 5 divides 0 is true. 5 divides 0 is true. Division by 0 is not defined, but every integer divides 0. So x minus 6 is divisible by 5. That means xx belongs to R, or I write in terms of this notation, I write x r x for all x belongs to R. Or you can simply write relation is reflexive because 5 divides x minus 6. 5 divides 0. Therefore it is reflexive. Second, symmetric. When you say that relation is symmetric, if x r y implies y r x, then relation is symmetric. What do you mean by when you say that x r y here? If suppose 5 divides x minus y, then what happens? X r y. That is the meaning of x r y. 5 divides x minus y, then x r y. 5 divides x minus y implies 5 divides minus of x minus y. 5 divides y minus x. This implies y r x. You should have some knowledge about divisibility. Next, in the next video, I start simultaneously another topic, number theory. Very interesting topic it is. Set theory. Along with that topic, I start number theory also. In number theory, you will come across all these things. Divisibility properties. If A divides B, then A divides minus B also. 5 divides x minus y, then 5 divides minus of x minus y. 5 divides y minus x. Therefore, symmetric. Third one, transitive. What is the relation here? X r y if and only for x minus y is divisible by 5. Now, transitive. Why it is transitive? Transitive because suppose 5 divides x minus y and 5 divides y minus z. What do you mean by 5 divides x minus y? X r y. This is y r z. 5 divides y minus z means y r z. X r y, y r z. Now 5 divides x minus y, 5 divides y minus z. Then 5 divides x minus z. Because in the property of divisibility, if A divides B, A divides C, then A divides B plus C. 5 divides x minus y, 5 divides y minus z, therefore 5 divides x minus y plus y minus z. 5 divides x minus z. 5 divides x minus z means x, y, z. So, what do you get? X r y, y r z implies x r z, not y, x r z. Therefore, this implies it is transitive. Hence, this relation is, what is the relation? X r y if and only if x minus y is divisible by 5 is equivalence relation. See, this has been asked in the previous examination for 5 marks. For your semester end examination, this is very simple question. Usually one question is asked on this equivalence relation. Now let us consider some more examples in the next video. and as I told you earlier, I start that number theory simultaneously, that topic also. In next video, I start number theory also. What you have to do is, you have to go through the videos, and I give the notes also. Go through the notes, go through the videos. You can easily understand. Okay, bye. Thank you.